Hello and welcome. In this video, we're going to take a look at our final homework from Unit 6, Lesson 5, More Exponent Practice. Please remember to pause and rewind the video as necessary. Let's take a look. Question 1. Rewrite each of the following expressions in simplest form and without negative exponents. So I think the first step would be to take a look at that and take a look at that. We could take a look at that simultaneously. That would be the same as x to the 3 plus 7 all over x to the 6th. So this would be x to the 10th divided by x to the 6th, which is x to the 10 minus 6th, which is x to the 4th. Here we're going to take care of the numbers first. 5 goes into 5 once, 5 goes into 25 5 times, and let's place that 1/5 out front. Now let's focus on the variables. X, if I'm dividing same base, I subtract the exponents, so this is x to the 4 minus 10, or 1/5, x to the negative 6. Now we can't write it with negative exponents, so we're going to have to rewrite this as 1/5 times 1 over x to the positive 6th power, which would be 1 over 5x to the 6th power. Letter C, we're first going to begin by taking that 2 and applying it to each term on the top. Then we're going to take this third power and apply it to each term on the bottom. So this is really x cubed squared times y to the 4th squared over x cubed times y to the 1st power cubed. And we are literally going to be multiplying each of these as we're raising a power to a power in each case. The first one is going to be x to the 6th times y to the 8th all over x to the 9th times y to the 3rd. That's the same as x to the 6 minus 9 times y to the 8 minus 3, which is x to the negative 3, y to the positive 5. Well, this is the same as 1 over x to the positive 3 times y to the 5 over 1. Multiply across fractions. I don't know why I wrote equal sign there. It's supposed to be times. And this would be y to the 5th power over x to the 3rd power. And letter D, let's begin by taking that 5 and applying it to the 2 and the x cubed. So this is 2 to the 5th power times x to the 3rd to the 5th power, all over 8x to the negative 3rd power. Well, 2 to the 5th power is 2 times 2 times 2 times 2 times 2. That would be 32 x to the, multiply those, 15th power, over 8 x to the negative 3rd. Well, take care of those. 32 divided by 8 would be 4x. Since I'm dividing, I'm going to subtract the exponents. 15 minus a minus 3, which would be 4x to the 18th power. In part 2, it says, which of the following represents the value of a to the negative 4th, b to the negative 2, when a is 3 and b is 2? So I'm going to replace 3 with a and 2 with b, and then compute. So this is 3 to the negative 4th power over 2 to the negative 2nd power. Well, that's the same as 1 over 3 to the 4th power divided by 1 over 2 to the 2nd power. And when you're dividing a fraction by a fraction, you reciprocate and multiply. So that's the same as 1 over 3 to the 4th power times 2 to the 2nd power over 1, which is 4 over 81. Number 3, simplify each expression so that it contains no negative exponents. Do not use expressions using radicals. Okay, dealing with rational exponents now. Okay, first one, deal with the x's. This is the same as x to the 7/2 minus 3/4 times y to the 1/2 minus 2. Well, we need a common denominator here. Common denominator here would be 4, so I'm going to rewrite 7/2 into 14/4. I'm going to double each part. So this is x to the 14/4, 2 times 2, right? Minus 3/4, there's my common denominator, times y. Now I'm going to rewrite this as 4/2. So it's 1/2 minus 4/2. 4 divided by 2 is 2. Well, this is x to the 11/4 times y to the negative 3/2. Can't write with negative exponents, so I'm going to rewrite this as x to the 11/4 over 1 times 1 over y to the 3/2. This would be x to the 11/4 divided by y to the 3/2. Letter B, let's take that and let's apply the property where we multiply. Power to a power, we multiply. So this is x to the 1/3 times 4, or x to the 4/3 over x to the negative 2/3. Well, that ends up becoming x to the 4/3 minus a minus 2/3. Well, minus minus is a plus, so this is 4/3 plus 2/3, which becomes x to the 6/3. 6 divided by 3 is 2. This becomes x squared. Part C looks pretty crazy, but take it in pieces. Okay, start with the 5 and the 2. Start with the numbers. 5 times 2 is 10. Then take the x's. We're going to go x to the 2/3 plus 2. You have to add the fractions when you multiply. Same base, you add the fractions, add the exponents. And then y to the negative 1/2 plus negative 3. Again, you're multiplying y, so we're going to add our exponents. Well, this becomes 10x to the 2/3 plus 6/3. 6 divided by 3 is 2. Times y to the negative 1/2 plus negative 6/2. 6 divided by 2 is negative 3. Well, this is 10x to the 8/3 times y to the negative 7/2. Well, that's the same thing as 10x to the 8/3 over 1 times 1 over y to the positive 7/2. Multiply across the top and bottom, and we get 10x to the 8/3 over y to the 7/2 power. Number 4, which of the following expressions 24x to the negative 1/2 divided by 6x to the 5/2 written in simplest form. Okay, taking care of this, we're going to start with the numbers. 24 divided by 6 would be 4. X, since you have the same base, you're going to subtract your exponent. So it's negative 1/2 minus 5/2. This is 4x to the negative 6/2, which is 4x to the negative 3. Now, we need to write it without, I don't see 4x to the negative 3 in the list of answers here, so I'm going to rewrite it as a positive exponent. So this is 4 times 1 over x to the positive 3, but that's the same as 4 over x to the positive 3. And that is the first option over here. Number 5, rewrite each of the following expressions using radicals. Express your answers in simplest form. Well, let's use this property here. X to the m over m is the nth root of x to the m power. We're just going to apply this to everything. So this is simply the square root of 4x all to the third power. Well, I can rewrite that as the square root. I'm going to keep writing this 2 over here. 4 to the third power, you have to put that to both. That would be 64 x to the third power. Okay, now I'm going to split that up into what I can take the square root of and what I can't. So the square root of 64 is a perfect square, so I can take that. And x cubed, I'm going to break up into x squared times x to the first power. Now I can take the square root of 64, that would be 8. The square root of x squared would just be x, because 2 divided by 2 is 1, all times the square root of x. That stays under the radical. Part B. Let's begin by writing this as a positive exponent. So x to the negative 2/3 would be x 1 over x to the positive 2/3. We can rewrite this as 1 over the cube root of x squared. And there's nothing more than I can do to simplify that, because the root is bigger than the power. You can only simplify it when the root is even or smaller than the power. Part C, let's apply a power to a power. And we get x to the 12/5 power. Well, 5 is the root, 12 is the power, so this becomes the 5th root of x to the 12th power. Now, I can't, 5 is not divisible by 12, but it is divisible by 10, so I can break this up into the 5th root of x to the 10th power times x squared. And I can take the square root, or I can take the 5th root. The 5th root of x to the 10th power would be x squared, because again, 10 divided by 5 is 2. All times the 5th root of x squared. Let's start by rewriting these as fractional exponents. So the cube root of x is x to the 1/3 power. The square root of x is x to the 1/2 power. With same base, I subtract the exponents. So this becomes x to the 1/3 minus 1/2. Well, 1/3 minus 1/2, the common denominator would be 6. So that would be x to the 2/6 minus 3/6, which would be x to the negative 1/6, which you can rewrite as 1 over x to the positive 1/6. Now 6 is the root, m is the power. this is literally 1 over the 6th root of x to the first power, or simply 1 over the 6th root of x. Okay, this one looks hard, but break it into a bunch of exponents. So I can rewrite the square root of x as x to the 1/2 power times x squared all over x to the 5/3. So my first step was to transform that. My next step is going to be to add those exponents because I'm looking at same base. So we're going to go x to the 1/2 plus 2 all over x to the 5/3. Now x to the 1/2 plus 2 would be x to the 1/2 plus 4 over 2. 4 divided by 2 is 2. I want something with a denominator of 2 so I can add my fractions. All divided by x to the 5/3. Well, that's the same as x to the 5/2 over x to the 5/3. Now, since I'm dividing the same base, I'm going to now subtract those exponents. So this is x to the 5/2 minus 5/3. Well, 5/2 minus 5/3, the common denominator again is 6. So I'm going to multiply 3 times 3 over here. I'm going to multiply 2 times 2 over here. So this is really the same as x to the 15/6 minus 10/6, which is x to the 5/6, which is the 6th root of x to the 5th power. I can't simplify that anymore because the root is bigger than the power. Letter F. Let's see. I could rewrite this as 2 times x to the 1/3 power, all raised to the 3rd power, over 24x. Now let's take that 3rd power and apply it to the 2 and the x to the 1/3. So this is 2 to the 3rd power times x to the 1/3 to the 3rd power, all over 24x to the 1st power. So 8, multiply those. Now 1/3 times 3 is 1, so that's x to the 1st power over 24x to the 1st power. Actually, let me backtrack my mistake. That is a square root, not a cube root. Minor mistake there. That makes that 8x to the 3/2 power (8x to the 3/2 power) over 24x. Now 8 goes into 8 one time, 8 goes into 24 3 times, and so we get 1/3 times x to the 3/2 minus 1. Well, that's the same as 1/3 times x to the 3/2 minus 2/2. 2 divided by 2 is 1. We need a common denominator, which is the same as 1/3 times x to the 1/2 power. We can't write it in, we have to write the expression using radicals, so I need to change that into 1/3 times the square root of x, or square root of x divided by 3. Either of those is fine. Part 6. I want to change 5 times the square root of x over 20x cubed into its simplest form. Let's see which of the following is equal to that. So this would be 5 times x to the 1/2 power over 20x to the 3rd power. Now 5 goes into 5 once, 5 goes into 24 times. That would be 1/4 times x to the, now I'm going to divide same base, so I'll subtract exponents, 1/2 minus 3. That's the same as 1/4 times x to the 1/2 minus 6/2. 6/2, 6 divided by 2 is 3. Well, that would be the same as 1/4 times x to the negative 5/2. 1 minus 6 is negative 5. Which is 1/4 times 1/x to the 5/2, which is 1/4 times the square root of x to the 5th power. Which is number 4. Number 7, we have the square root of x times x over x to the negative 2. Well, this is going to be x to the 1/2 times x to the 1 over x to the negative 2. Take the top part, same base, multiplying same base, add the exponents. This becomes x to the 1/2 plus 1 over x to the negative 2. That's x to the 1/2 plus 2/2 over x to the negative 2, which is x to the 3/2 over x to the negative 2. Now, since I have dividing same base, I'm going to subtract those exponents. So this is x to the 3/2 minus a minus 2. Don't forget to minus the minus 2, which is really x to the 3/2 plus 2, which is x to the 3/2 plus 4/2, which is x to the 7/2. Number 8, x to the 1/3 times x to the 1/2 divided by x to the negative 1. Start by adding the exponents because you're multiplying same base. This is x to the 1/3 plus 1/2 all over x to the negative 1. Well, 1/3 would be x to the 2/6 plus x to the 3/6, because we need a common denominator of 6, right? Over x to the negative 1, that's x to the 5/6 over x to the negative 1. Since I'm dividing same base, I will go ahead and subtract my exponents. This is x to the 5/6 minus a minus 1, which is x to the 5/6 plus 1, or plus 6/6, which is x to the 11/6. Now, since that doesn't show up as any of the answers, I need to convert that into a root. So that would be the 6th root of, this would be the 6th root of 11, x to the 11th power. Which is option 4. I hope you found this helpful. Again, rewind and pause as necessary, and thank you.